Imagine the soft ache of anticipation in your mouth before the first bite of something bold, something alive with heat, and realize that this spark of sensation started life as a tiny seed pressed into the red earth of China. That seed grew into a chili pepper, carefully tended, nurtured with precision, and eventually harvested in great fields where millions of peppers await their destiny. From these fields, crisp and bright red, the peppers travel across borders to Vietnam, where they are transformed into rich, savory, shacha chili sauce, a condiment that hums with cultural story and complexity. At the very moment that sauce hits the dining table, it connects your palate to distant landscapes, the vast expanse of Chinese farmland, the bustling factories of Vietnamese production, and the ancient agricultural wisdom that guides every step. And just as chili peppers build heat, on the other side of Asia, another story unfolds, one of giant tropical fruits in Thailand. Jackfruits so large they resemble small footballs, ripening under the humid sun, eventually becoming crisp dried snacks enjoyed worldwide. This is not just food production, it's an unfolding narrative of earth, culture, technology, and human expertise woven across countries and traditions. Let's step into that tale and savor every detail. The journey of the chili begins long before harvest. Down in the earth, where farmers, sometimes families working generations, old plots prepare soil with care. They test pH, add compost, and blend in fertilizers so that when the seeds hit the ground, they germinate with vigor. Imagine rows of seedlings, 6-8 inches tall, growing in nurseries where temperature, humidity, and light are finely tuned to coax open their first leaves. These trays of seedlings grow rapidly. Within a week, they reach 5 centimeters. In 2 weeks 15, each plant is misted daily, given the right nutrients, shielded from pests and harsh sunlight. Farmers nearly speak to them, warming them in cooler seasons, shading them when necessary. At around 10 to 15 centimeters tall, these delicate plants, still fragile but strong enough, are carefully transplanted, each into its spot in the field, where lines of vivid green stretch on and on towards the horizon. Technology has revolutionized that transplanting process. Where once hands dug holes and placed each plant, now automatic transplanters move across the field, gently placing each seedling along perfect lines. Mechanical hands ensuring the root ball stays intact, and spacing between plants is precise, typically 30 to 50 centimeters, tailored to each variety. This guarantees every plant has its own space to soak in sunlight, stretch roots, and avoid competition. The level of detail in this is staggering. Some systems rely on GPS guidance, sensors checking soil depth and row alignment. Root temperature sensors prompt watering systems to adjust in real time. Farmers become monitors more than laborers, data and making small adjustments that cascade into healthier, higher-yielding plants down the line. Once planted, the irrigation system takes over, guided by both ancient wisdom and modern sensors. Drip tubes and sprinklers deliver water efficiently, preventing overwatering that can drown roots and invite disease. In dry spells, irrigation pulses more frequently. In wet seasons, mulches cover the soil to reduce evaporation and protect plants. Sensors in the ground report moisture levels. Weather stations on site forecast rain, and automated valves regulate water delivery precisely. Nutrients follow next. Farmers apply nitrogen before flowering, phosphorus and potassium at fruit set, and micronutrients throughout growth. They test leaves for deficiencies. Nutrient sprays delivered as foliar feed correct imbalances immediately, ensuring flower production stays strong and fruit sets heavy. Meanwhile, pests like aphids or whiteflies may arrive uninvited. Rather than blanket spraying chemicals, many farms use integrated pest management. Beneficial insects like ladybugs or parasitoid wasps patrol the leaves. Organic sprays such as neem oil and garlic chili extracts act as deterrents. Fungicides are applied only when disease pressure rises, timed perfectly according to humidity and temperature data. Some fields deploy sensors that monitor leaf wetness and temperature, sending alerts to farmer apps so responses are immediate. What's impressive is the fusion of tradition like crop rotation or cover cropping and high-tech innovations such as disease forecasting models. The result? Healthier plants that require less chemical input. Within 2 to 3 months of planting, the moment strikes when peppers gleam bright red and firm they're ripe. Farmers inspect them carefully, sniffing stems, examining flesh, checking firmness, On large farms, machines assist. Specialized harvesters travel through rows, gently plucking ripe peppers without bruising. Conveyors carry peppers into collection bins. Smart sensors detecting underripe fruit to avoid mixing colors. Yet, even with automation, human hands check quality. Green or underdeveloped peppers are removed. After sorting, the sun-bright red peppers are packed and shipped off, some by refrigerated trucks, others in ventilated crates to processing centers where their real transformation begins. At the Vietnamese factory, often near ports like Hapong peppers, arrive at dawn or night to beat the heat. They're unloaded, washed meticulously under pressure to remove dirt, and sterilized to eliminate bacteria or residue. Sorting machines separate peppers by size and color, and only the best move forward. Those not up to standard head off to be used as animal feed or fertilizer. The premium peppers next undergo milling. High-speed grinders or traditional stone mills reduce them to a smooth paste. As the chili paste forms, precise proportions of garlic, sugar, salt, vinegar, and secret spices, sometimes including toasted sesame oil or dried shrimp, are blended in. Flavor technicians measure bricks pH and spice heat to ensure each batch fits the brand's profile. With paste ready, cooking begins. In large stainless steel cookers, temperatures are kept between 75 and 85 degrees Celsius. This cooks the paste evenly while preserving color, aroma, and flavor. The process kills off bacteria and stabilizes the sauce's texture. Workers, lab technicians, and plant operators monitor temperature probes, pH meters, and viscosity sensors in real time, ensuring consistency. Once cooking completes, the sauce moves to filters. Seeds, skins, and pulp are removed, leaving a silky, thick sauce. The sauce is cooled rapidly to preserve fragrance, then sent to bottling lines. Sterilized glass or plastic bottles are filled by automated nozzles, sealed, date-coded, and labeled. Quality-controlled teams conduct final tests. Taste panels assess spice intensity. Color meters analyze shade consistency. Microbial labs confirm safety. Only after passing every checkpoint does the sauce get packed into cartons bound for markets across Asia, Europe, and North America. Each bottle represents not only flavor, but hours of work by farmers, factory staff, transporters, and quality inspectors. Meanwhile, far to the south in Thailand, other fields yield a very different fruit. The giant jackfruit, heavy and sweet, hanging from tropical orchards under intense sun and rain. Farmers use grafted seedlings for consistency, because grafting ensures trees bear quality fruit faster, often in 3 to 4 years rather than 5 or 6. Each tree stands 8 to 12 meters from its neighbor, each branch carefully pruned to support fruit clusters that may weigh up to 30 kilograms each. Soil, sandy loam with a pH near 6 to 7.5, drains well and supports root growth. Tree care is constant. Irrigation during dry months, mulching to retain moisture, and pruning to boost airflow and remove dead branches. Pest issues, flies, aphids, mealybugs are managed organically with beneficial insects and botanical sprays. Disease-resistant varieties and field sanitation prevent stem rot or leaf blight. This orchard management is part science and part patience. Once those first jackfruits appear, farmers test maturity carefully. Color shifts from bright green to golden brown. Tapping fruit yields a hollow tone, and a tropical sweetness emanates near the stem. When ready, harvesters use long pole knives to cut the heavyweight fruits carefully without harming tree limbs. After harvest, the fruits are moved quickly to facilities where the next phase begins: washing, peeling, and slicing. Each fruit is clean debris and microbes removed, then peeled either by hand or with specialized machines, separating the golden yellow flesh from seeds and fibers. The leftover parts are composted or used as organic fertilizer. Goes to waste. Technicians slice the flesh into uniform strips or chunks following exact specifications to balance crispness and drying time. They avoid washing the flesh again after slicing to retain natural sweetness. Next comes flash freezing. Pieces are frozen at approximately -35 degrees Celsius, often forming a delicate frost or snow-like layer across their surface. This preserves texture, sweetness, and nutrients for the next phase: vacuum frying. The vacuum frying method is remarkably occurs at low pressure, so water evaporates at lower temperatures, reducing thermal damage and retaining flavor. As the fruit begins to crisp, up to 70% of the original nutrients and aroma remain intact. After frying, machines gently extract residual oil from the chips so they can stay shelf-stable. The finished product is light yellow, crisp, naturally sweet, aromatic, and free of additives. Packaging steps follow. Workers pack the chips in moisture-proof pouches, flushed with nitrogen, sealed tight, and labeled carefully. In recent years, demand for these chips has skyrocketed, driven by health trends and exotic snack enthusiasm, with Thai exports of jackfruit chips increasing